I will look into how an RS flip-flop, NOR gate RS flip-flop works. So the RS there, the truth table, QT is the Q here at present state, and QT plus 1 is the next state, which actually changes after the any of the input changes. So that's there. And then this is a NOR gate, so the NOR gate truth table I will draw here 0001 1011. So it's just opposite of OR, so it becomes 11 is 00 is, so like that, just the opposite of OR. That's the NOR gate which we will need. So let's start with 0 0, both are 0 here, so 0 here, 0 here, and let's say arbitrarily this was 1 here, Q, and Q bar was 0 here. So now this one is coming here, 1, so 1 and 0 in this, the input of this NOR gate. So 1 and 0 gives 0, so the output is 0, and this 0 will again appear here as 0, so 0 0 here as an input, which the output is 1. So basically we see that it doesn't change. So whatever it was, it doesn't change. We can try other combinations, but we will see that it doesn't change. So let's say I will actually erase all these things because I will do other ones. So basically this one is holds or stays the same, no change, we can say, no change. Now let's look at other combinations, 0 and 1. So this is 0 here, and this one is 1 there, and let's say this is 1 and 0 as it is. Just we can start with any output actually, because that's the, so this is 1 here, that means this is 1 here, that's the present state, and this one will contribute, so this present state will also contribute to the final output, which is the next state. So this one again is here 1, and this 1 and 1 is giving 0 here, and then this 0 is here, and this 0 0 is giving a 1 there. We see that it also hasn't changed, but there may be something else as well. So let's change the output. Let's say we have what I will do now is this one. Let's say this one starts from 0 and 1. So this one was 0 and this one was 1, with the same 0 1 here, and this one was 0 1. So I'm starting from a different Q present, or QT. So this is now 0. Let's see what happens. Now this one is 0, this 0 will be here again 0, and 0 1 is giving 0, so now it has changed, and this 0 will appear here as 0. So both inputs are 0 in this NOR gate, and 0 0 will give an 1 here. So we see that this Q has changed already, but this is still not over, because this Q has changed. That means this one here, I will use a different color now maybe. So this one actually has changed. This is not 0 anymore, this is 1. Now how this change affects the output, we have to again look at that. So this is 1, this is 1, it was previously 0, so it has this, now the inputs are this one, and previously it was one of these. So basically we see that the output doesn't change, this will stay 0, so it will stay the same actually. And since this one doesn't change, this one doesn't change either, so this one stays 1. So basically QT was 0, but QT plus 1 has become 1. So that's there, that's done. Now I will erase all these things again. It will take time this way though, but yeah, okay, so sort of done. So now let's see if R is 1 and S is 0, what happens. So we will change that. R is 1 and S is 0. So R is 1, S is 0, and let's say this one is maybe we can change it, or we can let's leave it like that, or let's do it 1 and 0, whatever, because we will try to see whether it changes or not. So let's say this is 0 here, this was 1 here, so let's leave it at 1 actually. Yeah, I think that will be better. So this is 1 and this is 0. Let's leave it like that. Whatever it was, I haven't changed. So basically 1 0, so it has become 1 there. Hold, I forgot to write. I think this one changed to 1. I think this one was 0 previously, and this one has changed to 1. But anyway, now this is R is 1 and S is 0. So this is 1 here. This one appears here, and 1 0 gives us a 0 here. And then let me use another color. This 0 is appearing here, and this 1 0 is giving 0 here. So this has already changed. It was 1 previously, now it has changed to 0. So of course our this input here, because this input has changed, it has become 0. So it was 1 0 previously, now it is 0 0. So it was some 1 0, this one or this one, whatever we say, was previously, but now it has become 0 0. This, so since this has changed, this will change as well to 1, and this has become 1. So this thing, which is this one, the input of this OR gate, it is getting very clumsy, but whatever, this one has changed to 1. So I will erase and write probably once again. So it has become 1 there. So this is 1, this is this one actually, and this is 1 as well. So this one is, previously it was, this one was 1 and this one was 0. So basically previously it was this one or this one, and now with the change it has become 1 1. So this one, so the output will 1 1 will give 0. So 1 1 will give 0 here, the same. This one doesn't change actually, this output doesn't change, and it stays 0 there. So our final output is 0 and 1, that is the Q bar. So basically this one we started from 1 here and it has changed to 0. So that's the change actually, and we are just writing the Q's though. And now let's see what happens if we do 1 1. So both inputs are 1. So yeah, I will actually erase first everything and then I will do that. Or maybe I will do manually because it's getting very clumsy here and it will take time consuming. It will be time consuming, sorry. Yeah, sort of erase it and then we'll do it. Anyway, yeah, so I will have to redraw this part. This one is coming from here and this one is going here, and this is R. So we are doing 1 and 1, both are 1, and see what happens, and we will see that this has become invalid. So let's start with any output. So let's say QT is 1 now, and when both are 1, this is 1 here, this one is coming here, 1 1. So this 1 1 will give 0 here, and this 0 will be here, this 0 will be here, and so this 1 0 is giving 0 here. So, and this has changed again, so this is, instead of 1, this will become 0. So 0 and 1 is still the output is 0. So, and this one doesn't change anymore because this was already 0. This input is already 0 and this one was 0, so this one is 0, so it hasn't changed. So this input here hasn't changed, so this one will stay 0. So we can see that both the outputs are 0, but in this for a flip-flop we are supposed to get one is the normal output and one is the inverted output, and we are not getting it. So basically for this kind of flip-flop, RS flip-flop, which is made of NOR gate with this connection, we cannot give 1 1 as a valid input, because that will not result result in an invalid function of the flip-flop. The flip-flop will not give normal output and inverted output. Both the outputs will be the same. So we will consider 1 1 as an invalid input. So basically it's invalid. The inputs will not be given, because if the input is given, the flip-flop will not work as it is expected. So yeah, that's what it is. And if we observe that when S is 1, output QT plus 1, which is actually the output, becomes 1, and when S is 0, this one becomes 0. I didn't write it, it changed to 0 actually. When 1 and 0, output changed to 0. So basically the output is following the S, which can be said set input. When set is 1, output is becoming 1. When set is 0, output is becoming 0. Anyway, we'll finish. This video is already very long.